You can start recording. Okay, so yeah, so welcome. And we have a lot of things to go through today. We have to go through the topics for this week. That means the week that is behind us. The arrays and lists, hash tables, or dictionaries or hash maps, and then hash sets or sets, and then tuples. And then we also introduce the topics for God willing next week. And then just discuss a few logistics and and answer questions people may have, right? So, quick question: was everyone able to go through the topics for this week? Was everyone able to go through them? There were only four topics. Was everyone able to go through them? Who didn't see the topics? Who didn't see the topics? If you didn't see, can you put a reaction or something? Who didn't see the topics? Um, like everybody saw them, right? Okay. Now, who couldn't go through all the resources or all the questions on Meet Code? Who couldn't go through them all? So everybody was able to go through them all. Okay, one person couldn't go through everything. Um, okay, I highly advise you go through them all as early as you can. Here's the reason. We are going to, as you saw, let me show you something. Let me show you something very quickly. Can you see my screen?
Yeah.
Okay. So given per roadmap, these are the questions we are doing right now. Need code 150, right? We're doing the arrays and hashing, easy and medium, right? I really need you to go through all these topics within the week we assign. Like whatever questions we assign, please do your best and go through every single one of them. God willing, sometime in July, right, or even sometime later in June, we will come back and we'll switch to need code 250, and then we'll fill in the gaps of the questions we left in, right? But the 150 questions that we are doing now, it's actually enough to give you such a solid foundation, such that even if you have an interview before we go to the 250 to fill in the gaps for the remaining questions, like even have an interview before, then you still be okay and you still be fine, right? That is one thing. The other thing also is that when you learn the topic, like some of you know lists already, you know stacks, you know queues already. Knowing the theoretical concept is very different from applying them or solving questions with them. Trust me, it's so different, right? And there are like some algorithms or some techniques you never come across or think about when you just go through the resources or watch the video, read the textbook. There's some things you never come across, but as you do the practice questions, you come across these things and then you just improve and become better. So I beg you, please go through the questions. I beg you, really, please make time and go through the questions. The other thing also I realized I didn't mention last week is that when it comes to decide to do the questions, please don't do the question on the Neat Code website. For now, I don't really advise you to do that. I really don't. I know he's done, he put in effort, but for now, just don't do that. Go click that external link button and go to the LeetCode website. Do everything on LeetCode so that you can also create lists and you can see other people's solutions. I said whenever you're able to, whenever you're done solving a question, don't just submit. We talk about this question today. When we did the coding room, when was it? It was Wednesday or Thursday, right? We went through like different implementations of the same thing, which work. Some were better than others. And sometimes the easiest way to see it is if you come to the solutions on LeetCode, and as I said, you sort by most votes, choose the language you want, and then you see other people's solution. If you just use the Needs Code website, you may not get all these benefits. So please do it on the Needs Code site if you may. If you want to do it too, fine, but I advise you do it on the other side, and so on and so forth. Sounds good. Also, it keeps all your practice at one place, right? And so on and so forth. Okay, so let's start with today's topic. On we go. Okay, are we good to start? Um, Stop share. Are we good to go?
Yeah.
Okay. Today we're going to let me connect. And please, one last thing I wanted to say. Look, we don't have much time on these workshop meetings. And when we don't have much time on these workshop meetings, we try to distill what we bring. Like we bring only the very important stuff, which means that every single thing we discuss here or we teach here, please understand it and cherish it. Like I've gone through some of these questions we're going through and all these things, and I've done a couple of interviews by God's grace. So I know the things that are relevant, right? Which I've used. So please, whenever we discuss something, an algorithm, how to approach things, please take it so seriously and cherish it. Don't think it is like useless or it is one of those extra things, optional things to know. No, everything we discuss here is mandatory to know. If I get to some place where I think this thing is something not so mandatory, I say it, right? If you remember from last year, a couple of years ago, and maybe I'm showing something, I'm like, this thing is not so cool one. I actually tell you. But if I don't say that, please, like, take it World Cup and don't let it slip by you. Okay, now let me turn on this. Don't start. Okay. Can everyone see my screen?
Yes, yes.
Yeah.
Okay, good stuff. Now we are going pop. If you have a question, send a message to the chat or just interrupt me like question or like emoji reaction, something, anything, right? And then we are there because we are moving fast and we want everybody to understand. Okay, so what is this? Okay. So basically the first part of our whole workshop is focused on data structures and algorithms, right? Data structures and algorithms. Right. And basically, we're going to focus more on the data structures part. And for each data structure, we'll consider some popular algorithms or some algorithms that apply to the data structures. Algorithms are simply ways of solving a problem. That's one ways of solving a problem, right? Ways of solving a problem. That's what an algorithm is. So for instance, cooking recipe, right? Like cooking recipe, like how do you cook this food? We like put 5 cups of rice, put salt, put ginger, put water, all these things. That's basically what an algorithm is, just a way of doing something, right? And as you can see, like right now, if I ask some of you to do maybe jollof, Ghanaian jollof, authentic Ghanaian jollof, everybody here can do it, right? Because maybe you've not learned it before or something like that, right? So in the same way, computer science algorithms, not every one of them you know, right? But if you learn how to make the jollof, then indeed you can do it. So that's something to keep in mind. But some algorithms, you probably never know them unless you learn them, right? So with that open-minded, you have to learn some algorithms to be comfortable with them. Some you may already know, right? So maybe when I'm like reverse a string. Sorry, let me increase my noise cancellation to make sure that okay, it's already high. Okay, that's fine. Okay, so that's what an algorithm, a way of solving a problem, right? Now, data structures. Data structures are just ways of representing or storing data. That's basically what a data structure is. It's just a way of representing or storing data, right? So you can have some data, let's say your name, right? Let's say my name, and then I'm like, I want to store my name in some way or in some format inside my computer, right? A data structure allows me to achieve that purpose. So just a way of representing or storing your data. That's what a data structure is. An algorithm is simply a way of doing things. Okay. So on that note, let's go to the next thing. Okay, so the next thing, so this is the first one we're going to start with is the array. So is the array. So array is actually a data structure. In other words, an array is a way of representing or storing information in a computer. And we are going to assume our computer memory. So you store data in, let's call it the computer memory. Memory just like computer storage. It's actually in a format like this. So you can assume it to be in a format like this, like chunk of blocks, right? Chunk of blocks like this. Please follow this part very carefully. Chunk a block like this. So this is how your computer storage system looks like. And each of these ones, we're going to call it a cell. So this is a cell. Can I get something like, so this is a cell, right? This is a cell. All these are actually cells, right? They are cells. So you think of it as like some neighborhood in your community, and all these are cells. Now, every cell here has an address. Let's call it an address. So this address, we're going to call an address an ID. So let's say this is address 1, so ID 1. This may be ID 8, right? Or let's call it ID 8. This may be ID 13, right? So every chunk, every cell inside your computer, right? Inside the storage actually has what we call an address, right? So let's say ID 32. Later on, when we go on, we learn something like, we call something the stack, the heap, and everything, learn them. But for now, let's generalize everything. So this is what we call addresses, right? So this is basically how it looks like. So when we talk about the array data structure, that allows us to store information inside this computer storage in a contiguous manner. In a contiguous manner. So what I mean by contiguous manner is, you've already gone through the resource and everything, so I'm not going to teach everything from scratch. I'm not saying they're very important things which may not be in those videos, right? Okay, so in a contiguous manner. So for instance, you already saw that Python, we usually use what we call a list, right? There's actually a difference which we touch on later. So let's say I want to store a list of numbers, 1, 2, 3, 4, right? For lists, what we do is that we actually end up storing it in a computer in a contiguous manner. What that means is that if I want to store 1, 2, 3, 4, I need to look for 4 consecutive cells, right? 4 consecutive cells in my storage. So I can use let's change the color. I can use 1, 2, 3, 4, right? 1, 2, 3, 4. These 4 cells, wait, 1, 2, 3, 4, right? To store it. So then when I create a list, this is what I'm doing. I'm actually getting 4 consecutive cells to store that information. And this is actually a big superpower. And here's this big superpower of that. We already established that every cell has an address, right? Has an address. So let's say this is address ID, let's call it ID 10. It has an address ID 10, right? It has an address ID 10. That means that the moment I get to address ID 10, it is very easy for me to find ID 11, find ID 12, find ID 13, right? Because all I need to do is to add some number, right? Add some number. Let's call it 1. Let's assume 1. It's actually not 1, but let's say 1, right? I need to just add 1 to it, and then on and off I go. So that's the first I want you to keep in mind. That let's store data in your memory in the form of a contiguous manner, in a contiguous array like this. And because of that, it is very easy to go from one level to the other level, from one cell to the next cell to the next cell. Okay. It's possible to go from one cell to the next cell, then to the next cell, and then to the next cell. Now, because that is very good, or because that is like very easy for the computer to compute, whenever we create a list like list L is equal to 1, 2, 3, what the computer actually does is 1, 2, 3, 4. What the computer actually does is that it comes to this the computer storage, then it creates this thing here, like we have here, and then it returns the address of the first one. So it returns the address of the first one and puts that one in L. Please listen to this part very carefully. Whenever we create a list, what actually happens is that the computer comes, it creates the 1, 2, 3, 4, like we have here, 1, 2, 3, 4, right? So it puts the 1, 2, 3, 4 here, like 1, 2, 3, 4, and then it returns the address of the first position. So here to return ID 10, right? So return ID 10. So then it should be like, so then what the computer does, it becomes L is equal to ID 10. So it just returns the ID 10, right? It returns the ID 10 and then assigns that to L. Does that make sense to everyone? When I create a list, this is what happens. It comes, creates the 1, 2, 3, 4 inside here. Then it returns the address of the first cell. Then it puts assigns that one to your variable. Now, because it has done that, it is very easy for it to find the next one, to find the next one, to find the next one. Because if it knows that L is ID 10, when it wants to find, let's say, the second one, the second cell, all it needs to do is to add +1, then it's at the next one. +1 is at the next one. +1 is at the next one. Does this make sense to everyone? What happens when I create a list? Does this make sense to everyone? What happens when we create a list?
Yeah.
Yeah.
Now, this thing is like super important and something you should know, because when you influence a lot of things you'll be doing, that when you create a list, this is what happens. It comes to the computer storage, it creates it, then it returns the address of the first one, the address of the ID 10 here. That is, so when I do list index 0, all it does is that it takes this ID 10, right? List index 0, and then it gives me the value that is stored there. If I do list index 1, what it does is that it takes that ID 10, then it adds +1 to it, right? So then becomes, go to ID 11 and give me whatever is stored there. And this is very important. This is like super important. That is why accessing from an array is very fast. It's called constant time, right? It's constant time. The reason why it's constant time is because it doesn't need to search through everything and be like, why is this? Why is this? Why is this? No. All it does is that it has access to the first address, right? Which is ID 10. So if I do list index 2, it just adds 2. It's like ID 10 plus 2, just like this address plus 2. Then it's like maybe ID 12. Then it just can easily jump to that place and then it just gives it to you. That is why accessing an array is constant time, because it just has the base address. It adds some constant number to it, like 1, and then it can easily jump there and then it gives you the number. Does that make sense to everyone?
Yes.
Okay. The next thing I want you to consider is what we call the reference types. Now, because when I create a list, what it does is that it gives the address, it gives the address to L. If I do L, let's start again. If I do L is equal to 1, 2, 3, let's call it L1. And I do L2 is equal to L1. What has actually happened now? Okay, let me actually ask you a question. And I do L2 is equal to L2 index 2 is equal to 5. First question number 1. I want everybody to answer this. When I print L1 index 2, what is the answer? And when I print L2 index 2, what is the answer? Can anybody help me? What will I get for the first one? What will be the answer for this? So this was line 1, line 2, then line 3. So if I print the first one, what do I get? What do I get?
This,
So what do I get for L1 index 2? Everybody put your answer in the chat, I beg. Everybody put your answer in the chat.
Loan time.
I get 3, right? Okay, 3. Now, what about the next one?
Was accusing me of
Please, can the person themselves? The person.
now?
There's somebody's. Okay. Okay, has everybody submitted the answer? Okay. So let's look at something here. So we all give our submissions, right? That I first do L1 is equal to 1, 2, 3. L2 is equal to L1. L2 index 2 is equal to 5. Then I did L1 index 2 is equal to 3. Then I did L1 index 2 and people said to give me 3. L2 index 2 is to give you 5. Truth is, that is actually not what happens. This is wrong. right? This is wrong. They'll both be 5. They'll both be 5. And this is the reason why they'll both be 5. You can try this and see. Why they'll both be 5 is this. We already established, that's why I said, please pay attention when I was talking about this, because it's very important. And it's something many people don't know, right? And that's what this workshop is supposed to do. It's supposed to fill in the gaps from the resources you went through. So when you did L is equal to 1, 2, 3, 4, or as we did here, L is equal to 1, 2, 3, what is stored in L1? What is stored in L1? N1 is the address, right? So it first comes to create the 1, 2, 3. So we can do it here like this. Where's that thing? So it first comes to find those 3 slots, right? Then it will so it first comes to find these 3 slots, right? And puts them there, right? So this is what it does. So 1, 2, 3. So it's like 1, 2, 3. So let's say the address of this is ID 15, right? ID 15. So the value of L1, let's write it here. So L1 actually contains ID 15. ID 15. This is what happens. When I do L2, so now you're on the second line. So this one does this. It's like it comes to create the list here. Then it returns the address of the first entry, that is ID 15, to this L1. When I do L2 is equal to L1, what it does is that it does the same thing, right? It assigns that ID 15 also to L2. So this is also ID 15. That's the same thing here. Does that make sense to everyone? So if you look at this, both the variables L1 and L2 are referencing the same address in the storage. Can you see they're both referencing the same space? Does that make sense to everyone? Can we all see it here? That's
Yeah.
L1
Yeah,
and L2.
Cornelius.
Yes.
So, based on the the table you have there,
Yes.
we see for the ID 13 we have 2 ID 13s, right? So is it
Sorry.
possible we can?
It was just
an example.
It was just an example. I wasn't
Okay.
the numbers. Yeah.
Okay,
So
okay. I just wanted to.
every address is unique. Yeah, every address is unique. Yeah, thanks for that. So yeah, so now both L1 and L2 are referencing the same address, right? So it's something like this. L1 is pointing to this first chunk, and L2 is also pointing to that same chunk, right? They're pointing to the same thing, which means that if I use L1 to make any changes to this chunk, it will affect L2. If I use L2 to also make a change to this chunk, it will affect L1. Does that make sense to everyone? So that change I did here, when I was like L2 index 2 should be 5, what happens is that it comes to L2, index 2 is like, okay, here plus 2. So it comes here. So at first, when I first did this, the value was 3. So then using L2, I changed it to 5. So now if I try to use L1 to also do, index 2, it's going to be like, okay, plus 2 is going to also give you 5. Does that make sense to everyone? Does that make sense?
Yes.
And this is a cause of problem of that and a lot of
Excuse me.
code. Yes, go on. Please ask your question.
So the L1 is just going to create there's L1 equals to 1, 2, 3 to just create it in the cell. Then
Yeah.
L2 referencing it. Then L2 index 2 is to go to the same cell and mutate the element that you want to do, then store it there. So everything is when you meet all the 3 variables are just pointing towards the same ID.
Yeah. So both
That's what you're
L1
trying to
so both L1
L2.
and L2 are pointing to the same address, right? So whatever change you do with this L1 guy, it will affect L2. Whatever change you do with this L2 guy will affect L1, right?
I see.
Right. So because of now, this is a cause of bugs in many. You don't write your own code and then you create a list. You are like, oh, let me create a copy of it, and then you just do this. This is not how to create a copy of a list. That is because they are reference types. When I say reference types, that means that when I say reference type, what I mean is that when you created this one, what is stored in L1 is actually a reference. It's actually an address, as you can see here. It's actually it's an address here that is stored in L1. It is different from when you assuming I did like N1, let's say N, that is number 1 is equal to 5. And I did number 2 is equal to 3, right? This one, what is stored in N1 is actually the value 5, right? So if I do I meant to do N2 is equal to N1. And I do N2 is equal to 10. Let's ask the next question. What would the value of N1 be? What will N1 be? What will N1 be? This is line 1, this is line 2, this is line 3. What will be the value of N1? Put in the chat. N1 will be 5, correct? Okay, what will be N2? N2 will be 10, correct? Exactly, right? Integers are not reference types, right? When I stored N1, when I did N1 is equal to 5, it actually puts 5 into N1's box. it put 5 inside it, right? And when I did N2, it created another box for N2, it put 5 in. So when I did this, when I did this line, it only changed this one to 10 now, right? Does that make sense to everyone? So this is like something very important to know. It's very, very important to know. Okay. So on that note, somebody will ask, how then can I create a copy, right? Like if so we will learn this does not create a copy of the actual data, right? This just duplicates like the reference, like the address, right? And so how can I create a copy of it? To create a copy, there are two types. We have what we call, so I've shown you that this is not how you create a copy of a list, right? This is not how you create like independent copies of lists, right? Instead, to create a copy, there are two types of copies. What we call shallow copy and deep copy, right? Shallow copy and deep copy. I think I should give you this actually as an assignment to go check in future. But I'm going to end this one here and keep this thing in mind. Sorry. Keep this thing in mind, what is happening here, right? Like if you do this and you go and mutate it, it's going to end up changing it. Okay, there's a question in the chat. Initializing a list, is this different from oh no, can anybody see that question in the chat? I want to show you something about that question in the chat. Can anybody see that question in the chat? Can everybody see the question in the chat? Okay, good question. Look at something here. So let's say you want to create a list. Let's call it nums. Look at this very carefully, please. Nums, right? I want to create a list of 5 integers. Look at this carefully, 5 integers. So let's say a list of 5 entries. Let's say all of them are 0. Let's make it 4, right? This is what I want to create. There are a couple of ways to create it. Number one, I can do this. I'm going to show you, there's a scary part about this way of writing code, but look at this. I can do this times 4. This will work, right? I can also do this. Please look at this carefully. If you don't know how to write code like this, it's time for you to learn. Like as we teach it like then you learn it, right? Okay, you can also do this 0 for this. I told you to learn loops, for loops, right? Like, okay, for underscore in range 4. Whenever you're writing code and you not be using that variable, feel free to use an underscore for it, right? Like you see here, I could have written I. Look, I could have written I here, right? But I realize that I don't use it in the body, right? I don't use the I here. Can everybody see it? Because I'm not going to use the I anywhere, you can feel free. And it also shows like if you're doing a coding interview and that is coding, the interview will be like, okay, this guy knows what he's doing, right? So I can use underscore here. But assuming I would use the variable like in the body, let's assume I'll be using the variable here. Let's assume I'll be doing like I for I in range. Because I'm using the I, because the I here is also being used here, then I can keep the I here. But if I'm not, I can just use an underscore for that. Does that make sense to everyone? Does that make sense to everyone? Okay.
Yeah.
I can just do 0 for underscore in this. Okay. Now, these two things will both give you whatever we have there. Do we agree or not? Do we agree? Does everyone agree? Who doesn't agree with this? Does everyone agree with this? Okay, this is perfect. This is correct. Now, let's come to the tricky part. The tricky part is now, let's assume we want to create a nested list. That is now, instead of our list containing numbers like this, we want them to contain inside list, right? So let's say a list of, let's say 1, 1, 1. Right? Let's assume we want to create this. So these are our targets now. Please look at this carefully. I'm trying to tell lists are actually reference types. They're not value types. These were values, so everything was perfect. Now, I want to create this. This is my target. Let's focus on this part, right? To create this target, so let's do the first one. The first one we did, similar to this guy. So I'll do nums is equal to, so as you can see, all we did that we do our square brackets. Look, we do our square brackets. Then let's change this to red. We do our square brackets. Then we just write one of them. Then we just like times, like multiply it 4 times. So you just take the entry, the thing inside them to multiply it 4 times, right? So let's do the same. So that's what's going to happen here. So it's going to be like 1. So sorry. So that's going to be like, we take the 1 here, right? Times 4. Does everybody agree? Does everybody agree with what I've written here? Does everybody agree with what I've written here?
Yeah.
Okay, good. Thank you. Okay, now let's go to the next one. Then the next one, what do? We do 1 for underscore in range 4. Does everybody also agree with this one? Like what I just did? Like I'm just taking this and I'm just translated it to this. Can everybody see it?
Yes.
Okay. Now, so now we have, so just for continuing from this part, let's call it A, right? And let's call this one B. So for A, let's call it nums1, and let's call this one nums2, right? So for nums1, I have 1, 1, 1, 1, right? it was 4 times, right? And for B, which is nums2, I have, please follow me carefully. 1, 1, 1, 1. Right? Now, questions again. When I do nums1 of 1, we all know how to add something to a list, right? But append, right? If you don't know, please, you know it now. But append 0. And now I do nums. Give me nums1 of 2. So this is question 1. Question 2. Then I did nums2 dot append nums2 of 1 dot append 0. And then give me nums. Please follow me carefully. Nums2 of 2. Okay, so now I want what I'll get for these things. Let me go through what I have here. So what I did was that I did this, we did this. Everybody understood this part, right? The next thing I did was, so this is the output I get for them, right? Then I take the first one, this first one. Then I do nums1 index 1. Nums1 index 1 gives me this entry here, this guy here. Do you all see it here? This is nums1 index 1. Do you all agree? Nums1 index 1. This is index 0, this index 1. Can we all see it here? And that is a list.
Yeah.
Okay. And then I did dot append 0, right? So first of all, what does this become? What does this become? This entry here, what does it become? Anybody can help me? What does this become?
1 0.
It becomes 1 0. Do you all agree? Okay. Now let's go to the next one. Now then let's come here. I did nums2 index 1 dot append 0. So that is also, what does this one also become? What does this become? What does this become?
1 0.
1 0. I hope you all agree. Please follow me carefully. 1 0. Okay. Now let's go to the questions. What is nums1 index 2? What is this? What does this become? Does this maintain as it is or something happens to it? Anyone?
It maintains.
It maintains. Okay. Okay. What about nums2 index 2? What about this one too? Does it maintain or something happens to it? Anyone? People are confused now. People are like, they're not even sure what they think. Anyone? What do you think happens? No, feel free to like just anything you want. Maintain. So
It remains the same.
okay, good. Thank you so much for submission. I'm going to announce to you that the first one will change, but the second one will remain the same. This is what actually happens. The first one will change, the second one will remain the same. And this is why. This is what happened. Wait, do we all see it? This is what happened. You see that code we have here? Can you see the code we have here? Can you see how we created nums1? Can we all see it?
Yeah.
This is actually what we did for nums1. When we did this, when we wrote this code, what happened was that it first created the list for the first one. Let's say it gave it an address of ID2. Then it's duplicated ID2 4 times. ID2, ID2. So when I did nums1 index 1 dot append 0, right? I took ID2 and I used ID2 to append 0. If I use ID2 to append 0, aren't all these pointing to the same things? And they're pointing to the same thing. So if I use the second one to make a change, won't everyone feel it? As we saw here. Won't everyone feel it? Right? Everybody will end up feeling it. Does that make sense to everyone?
Deep.
Right. Everybody is going to feel it, right? Because of how you created it. When you did that times 4, what you did was, hey, create one of it and then multiply it 4 times. It's very different from this case. These ones were values, right? They were values. They were actually values, right? But this one, the type here is actually a list. But what I did here was different. What I did here was like this. I was like, hey, create this 4 times. It was like, create this on every iteration. So here, for every time that the loop executes, a new one is created. So here, this one could be ID1, this could be ID2, it could be ID3. They have different addresses and ID4. So whenever you're solving a question or something, and you want to create, like list, like K number of times, please don't use this. It's going to lead to a bug. Do this. Or you can just create your empty list. If you can just create your empty, you can just be like nums3 is equal to the empty list. Then you can do a for loop for I in range 4, right? It can be like nums3.append, right? Because when you do nums3.append, your empty list, that one you're creating a new list each time, right? So this you want to do is actually the second one, not the first one. Does that make sense to everyone? Because lists are reference types. Lists are reference types. So if you just make copies of lists like this, what you've actually done is that you've just made copies of the same thing, and you can use one to make change and to affect all the others. Does that make sense to everyone? Does it make sense to everyone?
Yes.
Okay. There's a question in the chat. Let's all look at that. Anyone see the question Prince sent? So that somebody should give us an answer. What do we think? The question in the chat. When we on line 2, what will line 2 give us? And do line 2. Line 2, we all know line 2 be 3, right? Line 2 be 3. I hope you all agree. Line 2 be 3. The question in the chat. Okay. Now let's go to line 6. What will line 6 be? Line 6, L2 index 2. What will it be? Somebody should tell me what the value be. Print L2 index 2. That will be what? Will it
5.
be? It will be 5, right? It will be 5 because you're actually making a change. So that will be 5. Okay. So that's what I wanted to mention to you about lists. That this is something you probably didn't see in the videos you're watching, but lists are reference types. And for reference types, you can't, whenever you create like a reference type or like a list, like L1 is equal to, let's say like 2, like the list of 2, and you do L2 is equal to L1, know that they are pointing to the same place in memory. So if you make a change with this guy, to make a change with this guy. Now, look at something here. Somebody may think, look at this carefully. If I do L1 is equal to 2, and I do L2 is equal to L1, and I do L1 is equal to 3. Somebody, this is L, by the way, L. If I do print L2 index 0, what would the value be? What would the value be? Anybody, what would the value be? So print L1 index 0 and L2 index 0. What would the values be? Anyone? Tell me. Answers in chat.
3.
Be active about this. Even if you're wrong, like be active about it. It helps you like think about it, right? Okay. L1, so this will be 3, right? And this one will be 2. Do you all see it? This is what the answer will be, because look, here you first take it one at a time, right? Here L1 was ID 1. Let's say it was address 1, right? So here L2 now also becomes address 1. Okay. But look here, you're creating a new list, right? You're creating a new list. You create a new list in memory. Then you're like, oh, now reassign its address to L1, right? So that new list address will now be assigned to this guy. So let's say ID 10, right? So as you can see, L2 continues to map to ID 1, right? But L1 is now connecting. Basically, just remove the link, right? You just put something else into L1's box, right? But if I come down again, and I write L2 is equal to L1, then now I have changed this guy. Now L2 is going to contain ID 10. Does that make sense to everyone? Is that clear? Is that clear to everyone?
Yeah.
Please keep this in mind very carefully. Trust me, there's also bug in a lot of codes. I've written code.
Sorry, yes, I have a question.
Yeah,
I
go
want to clarify. So does it mean that with the A, like you're going to get 1-0 for all the entire elements in the list, not just the
with the A?
index of
Yes, exactly. Yeah, with the A,
Okay.
you get 1-0 for every one of them, right? Like, because they're all the same things, right? Like they're all ID2, 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 right? Because what you did, I just created the first one, then you just duplicated it 4 times, right? Just duplicated it 4 times. Does that make sense to everyone? But the second one,
Cornelius,
Yeah.
so are you saying like if you reassign it,
Mhm.
it's going to like for example, I was saying we saw the similar question today where it's this week products of array except self, where you actually can initialize the array by how you were initializing, like maybe multiply by the length of the array, right? Then after like multiplying by the length of the array, I remember we do something where we are like updating the value based on like the
Yeah.
left or the right.
Hope everybody
Yeah, you
solved
get
that
what I'm
question.
saying, right?
So you know what she's saying. So so if you look at that, question you should ask yourself is, what was the content of that list you created like this? Right? It was numbers, right? Numbers are not reference types, right? If it's a number, if you look at the number example we did here, if you create numbers, you can create, if you think your list is going to contain value types like this, like strings, or that way also to call it like immutable, what do you call it? Immutable types, right? Like if it's just numbers, you can create them this way, and you can change index 1, and you can change index 2, and it will just affect that particular one, right? Like product of array except self, what you did was you created a left one, right? Like a left one. And then you were like, maybe I'm going to make it 1 times n, right? And then you can do like left index 0 is equal to, like maybe it's equal to, let's say 20, right? Because this one is an integer, it only updates that. Because look, inside the list, it's only value types. They're only value types. Can everybody see it? If it's value types, like integers and strings, this thing is fine. It's going to work perfectly. Like if you do, like if your list was like A, like 10 times, right? And you change, let's say L index 0 to say B, it will affect only B, right? It will affect only B. But list, that will not happen. Does that make
Okay,
sense?
that makes sense. Yeah.
Yeah.
Got that.
Now, I saw a question in the chat. Somebody's like, okay, what if I do L2 is equal to L1? This. Has everybody seen this Python thing before? That's Python thing there. Has everybody seen it before?
Yes.
Yeah.
Yeah.
Now this, so if I have L1 is equal to the list 1, 2, 3, and I have L2 is equal to L1, this, what is going to happen? Actually, let me ask a question. Let me ask a question. Okay, so now I do L2 index. Let's change the second entry. So let's say 20, let's say 5. So question 1, what is L1 index 1 and L2 index 1? Anybody, please answer in chat. Please, I want everybody to be very proactive about these things. Like it's fine for you to get it wrong, to see your confusion, then we fix it, right? Like instead of being very, okay.
L1 index 1 is going to be 2.
Okay, they're saying 2, 5, right? So let's look at it here. So this thing we're doing here will create a copy of it. We'll create a copy of L1. So it's going to go to the space, but there's a caveat to it, but I want to show you something. But for now, look at this. So when it did this, it went to create some storage in memory, right? Then it's assigned the variable, it's assigned the address to L1. Then when I did this one, because of this guy, it's going to create another one, then to assign that to. So now they're independent, right? They're two independent things, right? But there's a caveat to it. This thing you're seeing here is actually a shallow. It's actually a shallow copy. What I mean is that it will just step into it once. It will step into it once. Please put this thing in mind, to step into it once. What I mean to say is this. Here, the level of nexting is just 1. In other words, it's just like 1, 2, 3. Assuming I had it to be like this. One, two, three, like this. Let's assume this was L1. Look at this. Let's assume this was L1. And then I do L2 is equal to L1, this. So here, yes, we are saying we've created copies of it, right? But if I do L2 index 0 dot append 5, look at what, let's go over what we've done here right now. So we first created this, right? Look, what is the entry? What is the entry? The entry is actually a reference type, right? What is inside it is actually a reference type. It's a list, right? When I do this copy thing, it only makes a copy of it only makes a copy of the top level thing, like the top level thing. It makes a copy of only the top level thing. It doesn't make a copy of everything inside. It only makes a copy of this thing. So what I mean to say is this, look at this, to make it even clearer. Everybody follow me carefully. Please don't make me look at everything carefully. Now, the big, look, I'm using a very easy way to remember it. The big list, right, is ID1. Then inside ID1, we have another list inside it, right? That will also have its address, right? Let's call that one ID10, right? When I do this thing, right, so now you have something like this. You have ID1 outside, and then has ID10 inside. Can everybody see what I just did here? Like this is equivalent to this. Can everybody see what I have here? Can everybody see it? Can everybody see this?
Yes.
Okay. So now this is what L1 looks like. When I do this thing here, what actually happens is this. It creates a copy of the top level one. So ID1, it creates a new copy of it. So let's call it ID20. Let's call it ID2. But then it does not step into it to make a copy of this. So it will still be ID10 inside here. Can everybody see what is happening here? So like at the top level, they have the different things, right? But when they step inside here, they're referencing the same thing. So that means that, so what that means is this. So this is an implication for that. When I do L2, oh, sorry. When I do L2, when I do this, L2 index 0, what is L2 index 0? L2 index 0 is ID10, right? And I make a change to it, right? By appending 5, it's going to affect L1 index 0 also. Can we all see it here? Can we all see that here? I'm explaining to you this thing, like what this thing does.
Yeah.
This is what we call a shallow copy. It's not a deep copy, it's a shallow copy, right? It's a shallow copy. That means that it only makes a copy at the top level, right? Because it's only a copy of the top level. However, if I do L2.append let's do, I do the L2 dot append, let's say 20, right? That one, if I print L2, right? If I print L2, L2 is going to contain like, this will be 1, 2, 3, which is like the first entry here. It's like the first entry I got from the copying, then you have 20. But if I print L1, it's only going to be 1, 2, 3. Because if you take a look again, like the top levels are different, right? The top levels are different. So you can make a change to the top level and they will be independent. But the moment you step inside, they're both containing that same list. And that is what we call a shallow copy. A shallow copy only copies it at the top level. It doesn't enter into it, doesn't step into it. Does that make sense to everyone?
Yeah.
Okay, please
Yeah.
make time to understand this. Great. Now, somebody will be like, well, what if I want to make everything inside different? We want to make everything inside different so that every change affects only that particular thing. That's what we call a deep copy. So we call a deep copy, right? That's why I wrote here, shallow copy and deep copy. I wrote it somewhere here. Shallow copy and deep copy, these two things, shallow copy and deep copy. And Python allows you to call, Python has a deep copy function. When you create a deep copy, Python has a deep copy function you can use. But I just want you to take note of this. So that's what we wanted to talk today about lists. The lists are reference types. When you're assigning lists, please be careful about that. And I also want you to keep in mind why lists, how lists are represented in memory, because that representation is what determines the time complexity of lists or arrays. This thing here. Please keep this thing in mind. That is what helps you determine the time complexity of lists or arrays. But next week, we're going to learn big O, how to determine time complexity and everything. As let me just mention it very strictly for lists. Then we go on to the next one, the hashing data structures. So can we all see, do we all have a picture of how lists are represented in memory? Can we all see that? Can we all see how like lists are represented in memory? If I create a list 1, 2, 3, 4, it comes to find 4 contiguous space, puts everything there contiguously, like consecutively, and then it returns the address to this one. Does that make sense to everyone? Does that representation make sense to everyone, please? Before we go into the next.
Yeah.
Now, because of this representation in memory, actually, the time complexity or the efficiency of the structures are dependent on how they are represented in memory. Because lists are represented in this way in memory, right? Their time complexity is relatively different. When we're considering the time complexity of data structures, we mainly consider like 4 operations. The 4 operations are as follows: insertion. Somebody help me. What else? Searching.
Deletion.
Deletion and what?
Reading.
Oh, reading. Exactly. Thank you. I think reading and searching, I feel like we can measure them, but it's fine, right? So look at something here. So let's look at insertion, right? So if I want to insert something into my array, look at something here. Please look at this carefully. Look at this very carefully. Don't forget the structure. This structure is so important. Trust me. Like when I learned array notes, like these are the kind of things I put in my mind, though. Like, I want to make a copy of this thing. How do I make a copy of this? Okay. Like, for me, one thing that really helped me with data structures was this. Like, I put the representations in my mind. And for me, that was a game changer. Whenever I put the representation in my mind, I feel like that was like really a game changer for me. So I want to know what insertion is, right? Now, if I want to insert into my list, look, I have a list 1, 2, 3. I want to insert. There are many things to consider, right? What do I mean by many things to consider? Well, I can, please follow me carefully. As I said, every time we are discussing here is things that are critical to know because you come across them. Trust me, you will. So if I want to insert something into a list, right? So I'm going to use the list because it's on Python. So if I want to insert something into a list, what I can do, if you look at this carefully, you can insert it at the front, you can insert it at the back, you can insert it inside, right? Somewhere in the middle, right? Or somewhere inside. Do you agree? Those are the 3 positions we can generally insert, right? Do you agree?
Yeah, right.
Okay.
Yeah.
And now we already discussed how arrays are created and how everything they are done, right? How they are created in memory and everything. So let's go to the first one. Let's assume I want to insert at the front. Please follow this carefully. If I want to insert at the front, we have already explained that whenever the array is created, what the computer does is that it returns the address. What the computer does is that it keeps the address of the first entry, right? And assign that one to the variable, right? Basically, the variable is the address of the first entry. That is what we do. That's what the computer does. Where's it? Highlighter, right? The address of the first entry. So if I try to insert something to the front, what happens is that the computer does not want to change the address. It's like ID 10. I'm going to keep L2 still pointing to ID 10. I'm not going to change that, right? It's like still be ID 10. But then you're like, okay, I want to put, let's say it's 8 to the front. but it doesn't want to change it. So therefore, what it has to do is that now it has to move everything backward. It has to move all these things backward. Like it has to shift everything backward. And then it will put the 8 in front, like 8, 1, 2, 3. So something like this. So what happens then is that it now removes this 1, and then it puts the 8 here, and then it pushes everything backward. 1, 2, 3, then 4. So now we have it something like, here's my highlighter. So now it extends it to beyond this. Does that make sense to everyone? What just happened? Like if you're inserting something into the array at the front, what happens is that it puts it there, and then it moves everything backward. It moves everything backward. So everything has to take a step backward. And then we still maintain our address at ID 10. So in other words, like, hey, 1 used to live in this address, but now 8 should live there. Every one of you go back, right? And then again, you can see that it has still maintained its structure, the contiguous nature of the array. Does that make sense to everyone? Does that make sense to everyone?
Yes, makes a lot of sense.
Yes.
So look, this is a lot of work we did, right? Look at the lot of work we did. We did a lot of work by, first, we had to insert this thing there, and then we have to move everything backward. Or think of it reverse. We have to move everyone backward. Everyone had to move backward. And then we got now a few slots here, and then we put this one here. Now, because we had to touch everything or move everything backward, the time complexity becomes O of n, where n is the length of the list, where n is the length of the list or the array, right? Because we have to move everything backward. And because we move everything backward, that's like we are doing work on every single entry, and therefore the time to move it is proportional to the number of entries. That's what we call linear time, because the amount of work we did is proportional to how many elements are there. Does that make sense to everyone?
I have a question.
Okay.
Yeah.
So that's what we call linear time. Yes, question.
Yeah, my question is, okay, we are trying to insert it into the list, right? Will it not kind of replace that one? How is the computer going to know, like, oh, we need to shift the element to the left?
Okay, so this is how the computer knows. So the computer knows that ID 10 is currently 1 living there, right? Then it knows that ID 11 is 2. ID, the next one is 3, right? Then he sees that you're trying to insert something here, and that is what they append. Let's say you're doing insert, right? You're like insert 8 at index 0, right? Then it comes like, we already have our list created there, right? And there's already 1 there and everything. But then you already did, let's say the thing is called nums, but you still want to keep that same ID 10 pointing to nums, right? The computer is like, well, if that is the case, then we still want to keep nums holding on to its ID 10. Now, there's actually somebody will be like, why don't we just, maybe put it in ID 9 and change nums to ID 9? The thing is, that will lead to a lot of issues in the code, because maybe you're using nums at different places in your program, right? Maybe you use this variable like a lot of places in your program, right? That changing the reference, maybe somebody's even doing something with the reference, right? So that can cause a lot of collisions. So that is why, that's another reason. It's why we'd rather now shift every one of these backward. Like these are just like number, they're just values inside cells, right? Like the cells are like kind of like the big deal. Like the cells are like another, it's like a house, as a house, right? Like, hey, you tenants, move to the next house. You tenants move to the next house. Well, there's a new tenant coming. These new tenants come and live here, right? That's how you should think about this. There's a new person coming to live in this neighborhood, but he wants this house. So you move here, you move here, you move here, right? It does something, a lot of things under the hood. Now, because of this thing, you realize that it's kind of a lot of work thinking about it. And that's the difference between an array and a list. Structural arrays, when you talk about arrays, like in C programming language and other programming languages, arrays does not allow this. Arrays does not allow you to change the size. For arrays, what we call arrays in typical computer science, arrays are declared with a fixed size, which means that if I create an array, so like in C programming, I'll be like, let's say int, and I create an array of size 8, that means that always it will have size 8, which means that it will go and look for 8 spaces, like it will go and look for 8 spaces in memory, and then to just, those 8 spaces, to go and look for 8 spaces in memory, and we'll only use those 8 spaces. It will not allow you to shrink down, it will not allow you to go up. That is what we call an array. It has a fixed size. But we also have something called dynamic array. But this is very restrictive, right? Because what if today I want 8, tomorrow I want 10, right? That's why computer scientists introduced what we call the dynamic array. A dynamic array allows you to resize, right? Dynamic array, that is kind of like what Python has, right? But that's what we call it Python list, right? That one allows you to resize. Like you can go lower, you can go bigger. There's something called, forget those basic, I mean, we can talk about it later, but like, yeah. So this is basically what it's
I still have a question.
yeah, go on.
I'm still on this insert. What's the difference between norms of I equals to, let me see, you're trying to impute number, like just like say norms of I, yeah, equals to 8.
Oh, yeah. So we're coming
Yeah.
to do that one.
Still-
Come to do that one next.
Because I still want, because there's one thing I was trying to, the time in my interview, I
Yeah.
can't forget it. I was trying to, the interviewer gave me 2 sorted lists, and he told me he wants me to the second sorted list and impute it to the first list in place. So
Yeah,
I
I'll come
was
to explain
kind
that
of,
one next. Yeah, that's the one I'm coming to explain next. So this what we just did was like you're inserting something new, right? Into some position. You're inserting something new, right? The next one, so you say can do the front, can insert a new number to the front. I mean, explain that it's linear time because you basically move everything, right? And that is a lot of work. Now let's go to when you want to put it at the back, right? Want to put it at the back. Well, at the back, what do I do? At the back, I just need to put the guy here. Look, at the back, I just
Hello, please, I have a question too.
okay. Let me finish this one. Let me take your question. Okay.
Okay.
So at the back, realize that at the back, I don't move anything. I just come, then I put the guy here, right? At the back, I don't put anything here. So at the back, all we do is that I have access to the first address, right? Then all I need to do is just compute, the length. Then I'm like, okay, put it at the back here. I don't move any guy. I don't move anything here. That is why insertion at the back or append for a list is constant time. It's constant time. Because you realize that I didn't move anything. There was no hard work to move. I didn't have to move any entries. No. I just have to come to the back and just append it there. And that is constant time. Then, so you've done front is linear, back is constant. Then becomes what about the middle? So usually the middle, it's kind of like, I'm like, is it the first or second position anywhere else? Then we generalize all of them to be linear time. So when you're adding something to a list, if it is not the back, the time complexity is, if it's not the back, the time complexity is linear time. It is only append that is constant time on the list. Please put that thing in mind. When you have a list, appending is constant time. Because what you do is that you just jump to the back and just append the thing there. You don't move anything. But all the others, you end up moving something. Look, if I want to insert it at the second position, 1, 2, 3, 4, 8. Let's say I want to bring 7. I want to put 7, let's say at the second position. What I have to do is that I have to maintain my one, put 7 here. Then I have to move every one of these. I have to move all these to the back. I have to shift everything back. So if I put in my 7, I have to now move 2 to the back. I have to move 3 to the back. I have to move 4 to the back, and so on and so forth we go, right? And this is still work that is being done. So we generalize and say it is on average linear time, O of n, where n is the length of the input. Now, let's come to the next thing I want to talk about is indexing. Indexing. Actually, I think that's what this is indexing, or I guess is people reading indexing. Now, because please, are we all following? Are we all following carefully? We just do arrays and hash structures today. Okay, let's look at indexing now. Now, indexing, because of the representation of arrays, look at how they are represented. Because they are represented like this, it is very easy for the computer to easily know what is at a particular address or a particular index. What I mean is this. When I create this, let's say this is L is equal to this. When I do L index 0, that is giving me the element at index 0 in my list. The computer can easily be like, oh, that is giving me the value at ID 10. This is what we call dereferencing. It's very easy for you to give it to you. If I do L index 2, is very fast. The computer can just be like, oh, L is ID 2. Just take 2 extra steps. So this is like this is L, right? It's like just take 2 extra steps. Like let's say this is L, this is one is L. Computer is just like just take 2 extra steps. So like indexing is constant time. Indexing for an array, indexing is constant. Like, I want you to understand why it is constant so that when you come across a question, it's very easy for you to solve. So indexing is constant. So whenever you do L index, so your list index, some K, some index, it is always constant time. Now, because it is constant time, whenever you're trying to change the value at some index, that is also constant time. What I mean is that if I do L index 2, it's equal to say 25, this is also constant time. It's constant time because to jump to L index 2 is very easy, right? It just needs to, you can easily jump, like, be like, oh, this is L index 2. Can easily jump to this space, L index 2. Then it's be like, oh, change the value here to 25. I didn't have to move anyone. Like, it just jumped, then it just changed the value. So when I change the value inside an array, that is also constant time. Does that make sense to everyone? Did what I say just make sense to everyone?
Yeah. Please, I also have a question, just in case
Okay,
you're
let's
done.
take questions now. So yeah, please ask the questions.
Yeah, so my question is, you see, when there's a new element added, let's say to the start of the array, right? It pushes the rest to, let's say, forward or backward, something like that. What if
there's something
the
there.
space there, it has been
So
assigned to
good.
something?
Good. So see, that's why you should always appreciate computer scientists, right? Look, so what he's saying is this. What if when I created the array, right? Like 1, 2, so these are the cells, right? These are the addresses, right? And then currently you have occupied like 1, 2, 3, right? And let's say there's some other data that is occupying this, right? That's what you're saying, right? And then you're like, oh, now let's bring some new guy. This first list is like,
Yeah.
oh, I want to insert some new guy. Therefore, it means that we have to move these guys backward. But there's some data here, right? There's some data here, right? That is going to end up exceeding over it, right? So this is actually a problem in computer science. This is one of the reasons people say don't write programming in C, right? Because as I told you, in C, when you create the array, it has fixed size, right? Let's say size 10, right? And then you're trying to write past size 10. Let's say now you're trying to append everyone and now make the size 11. What happens is you cause something called an overflow. That is one way people hack systems. They actually could do something called a buffer overflow. So buffer overflow, that is like you're writing past, like you're accessing data past the assigned, storage, right? Assigned space, right? But programming languages like Python and Java, on these ones have kind of like a computation under the hood to make this kind of changing easier, right? To make this kind of changing easier. One way is what we call dynamic allocation. That is to say that when you create your array, sometimes you're like, okay, I'm going to use a size 4. Some of the systems actually don't create size 4 for you. No, they actually kind of like, let's say they actually create something bigger. They create some extra space, right, to account for something like that, right? So you can look up dynamic allocation. You can also look up dynamic array. So that's actually what happens under the hood. Like the systems are built so intelligently that they don't make everything so compact because they know something like this may happen, right? So they have room for that. Sometimes, even what happens is this. Sometimes, let's assume you're changing a thing so many times. Let's assume that buffer they left, let's assume that space they left was just 2 cells. But now it's like you are going a lot. What happens is that they can relocate the whole data. They can move the whole data to some entirely new storage. Like they can move it to some space where there's like larger storage. But all these things are done under the hood. And it doesn't always happen. It may happen maybe once in your whole program execution. So even though it's linear at some point in the execution, we amortize it. Amortization. We spread it over everything and still say it's constant time. Some of the things we say constant doesn't necessarily means constant. It simply means that on average, like if we do everything over things, amortization next sessions. But that's what I just wanted to keep in mind, that the scientists have implemented this thing so beautifully that they have accounted for all these things under the hood. Yeah. But you can also look at buffer overflow. Yeah. Next question.
I think I saw somewhere that when you append something to let's say the list is 4, and when you append something to it, now the length of the list is going to be 5. Then to compensate for maybe adding things in the future is going to make the size of the list twice.
Yeah, exactly. That's the dynamic allocation. That's the dynamic array. So usually that is when it is getting to the end, right? It then resizes itself, right? That's what I'm saying. It doesn't keep it as compact like this, right? Like it doesn't need to keep it as, because the scientists know that something like this may happen, right? So actually what happens dynamically is sometimes this, that for dynamic arrays, let's assume you declare the array to be of like, let's say 4, right? Then you've put 1, 2, 3 in. Before you use the last entry, it will double the size. So another hood is actually 8 there, right? For you. So that's like, it says it for the future. And this doubling, so it's a doubling, like it's a double, then to copy everything inside that new array of size 8. But but copying everything is supposed to be linear time, right? But this doubling is not done always. Like it's done like very few times, right? So we call it amortization. It amortizes the cost of this over the entire cost. So that's what happens. But these are like kind of lower internals. Yeah. Any other questions?
Okay, my question is, I've understood that the insertion is linear time, but I want to understand that shouldn't it be n+1 steps, since you are moving everything backwards, n steps, and insertion will be 1.
Yeah, it's actually n+1 steps. But in time complex, what we do is that we kind of like we drop constants like this, right? It could be n+3 million, right? What we do is that we drop because realize this is always +1, it's always +1, it's always +1, right? We write big, unless we'll be doing big O more formally, right? Or when we just do it with the data together, right? So
what is +1? Is 1 the element?
Yeah, 1 is the insertion. So you're asking what amount of work is done? Well, the amount of work done is that if there are already 3 elements, I move 3 elements, so that's 3 work done. Then I perform the actual insertion, another work. So that +1 is like the actual insertion. But In big O, we drop the constants like even if
Yeah,
it's
we do that.
even if it's 3n, we drop the constants and say O of n, right? That's the right time.
N will be the work, while 1 will be the element.
Yeah. And so we say the amount of work that is proportional to the number of elements in it, right?
Yeah.
So what about deletion? Can anybody tell me deletion? So deletion, to say the same thing, we can delete from the front, we can delete from the back, we can delete from anywhere in the middle. So can anybody help me? What is deletion? What is the time complexity of deletion? If I want to delete, what is the time complexity? Let's start from back. Someone put in the chat in the back. What is the time complexity? Is it linear or constant from the back?
It's linear.
Constant, right? Because I just removed the thing. I don't need to move any other guy. I just remove it, then I just bring the thing here. What about from the front?
Linear.
It's linear, right?
Linear.
Because we have to move, because now this guy now becomes the new index 0, the new index 1, the new index 2, right? What about anywhere in the middle?
Yeah.
It's also linear, right? Because you can't leave a gap, right? You can't create a gap. It still has to be contiguous, right? That is also why it is linear. So do you understand the time complexity of arrays and how they're obtained? Does it make sense to everyone?
Yes.
How does it
Yeah.
make sense to everyone?
Yes, sir.
Okay, can we go on to the next thing? Can we go to the next thing? So this is basically things I wanted to keep in mind about an array. And look, an array is like a very general thing. Learn the common methods. Learn things like append. Learn things like pop or to delete. You can use pop, right? Like the pop. Pop takes. There are two types of pop. Yeah. I have to do a premium for this thing. Okay. There are two ways for pop. So you just do pop, like you do l.pop to remove the last one. But if you want to remove at some particular index, you pass the index to it. So pop has two signatures. You can have just pop like this. You can just pass an index to it, pop k. So if I do l.pop 0 like this, it removes the first entry. Does that make sense to everyone? So please learn these ones. Tu comprends?
Oui, monsieur.
Okay.
Oui.
Good. Okay. So we are going to the next one. Then we're almost done. We're just going to the hash chain discussion. I want to talk about that. Let me move on to it. I wanted to show you something. So what? So that means pop has a multi pop from the back is O of 1. But if you don't pop from the back, it becomes linear time. I hope you all know why, right? Pop from the back means remove from the back, right? Anywhere else becomes like so. Does that make sense to everyone?
Yeah.
Okay.
Don't seem to work with the index. So I kind of understand it better.
So what did you say?
Like working with the index to understand it better, like deleting and all this stuff. Like when you delete one element, you have to cover up the space if you delete from the
If you
end.
delete from the front, if you delete from some entry other than 0, you have to move the entries, and the moving them is extra work done. Now, this other thing, before we go to the hash tables one, I want to actually show you something. We are doing 2D lists, God willing. I want to show you the 2D list thing, and that's something everybody take your time. If you want to drink, water, go get your water now and come pay attention to this. So, how many of you solved the valid Sudoku questions? Put an emoji in the chat if you solve valid Sudoku. So when we did the coding room on Wednesday or something, when we responded to the questions, I told the people there that, I've even told those of you who have been here with us a couple of years now, it's not when you're writing code, right? When you're practicing, you can fix a way of writing your programs or writing your code. For instance, me, if I'm writing a function, I'm writing code, I don't spend time thinking, what should I call this variable? Or should I do this? And that is how you should be. Some things you don't have to think about them. You have to have a pattern of writing them. And I'm going to show you something. For instance, so how many of you did the valid Sudoku one? Okay, it's fine. How many of us have seen a question that involves like going through a grid, like an n by n matrix, like a nested list? How many of us have seen those questions before? Like I have to go through a grid or an n by n question. Hey, nobody has seen it before. Please put something in the chat or emoji and let me see. I want to know that we have a good number of people who know what I'm coming to say. I will have some experience, but I'll go over everything. Okay, so look at something here. Look what I'm going to show you here. So as I said, in writing programs, as a programmer, please have some way of writing some things, right? It's going to save you a lot of time. Like when you're doing the interview and stuff, you're not now come to be like, how do I iterate through this? How do I do this? No, you're going to waste your time. Look at something here. So this is what 2D lists are. Please everybody follow me carefully. 2D list. So 1, 2, 3, 4, 5, 6. Please, you must know this. When we get to graphs, use the same thing again. 7, 8, 9. Okay. This is what 2D lists look like. This is what we call 2D lists, right? In other words, you can represent them as a grid, as a matrix like this. is the same thing, right? I want to show you something you should know about them and something you should keep in mind without thinking. Whenever you have a question with 2D lists, I don't want you to think about how to iterate through them. Actually, trust me, I sat down to learn this because there was a time I used to actually be scared of them because I wasn't comfortable with them, right? Like, but I was like, man, you have to overcome this. So I was like, well, so right, I'm just going to show you the iterating through them. Iteration, like basically how to go through them. So when I have a 2D list like this, so let's say we have our list L like this. If I do L index 0, what is L index 0? Anyone? What is L index 0? Anyone? Help me. L index 0.
First list.
The first list, right? 1, 2, 3. Do you agree? Everybody agrees, correct? Do you agree, right? My question is, how do I iterate through a list? How do I print all the elements in this? Please, whenever you have to print or go through a 2D list, don't think. I'm going to show you how I write my code. If I have that question, that's you want to check, get all the even numbers in this grade. It is simple. It is easily peasily. Okay, let me show you. Me, if I get this code, that's what I do. So let's call that matrix. Let's say our 2D list is called matrix. Whenever I get this code, that's what I wrote. I write number of rows is equal to the length of the matrix. The number of columns is equal to. So yeah, we're assuming that it's n by we're assuming it's n by m, right? I'll explain that to Noah. It's matrix index 0. So what I'm saying is this. The number of rows is basically how many. These are the rows. That's why I wrote this way. 1, 2, 3. That is the same as the length of the matrix. Do you agree? Like 1, 2, 3. This is what we call rows. Rows are the horizontal ones. Everybody agrees to comprehend? Okay. So that's that. Then columns. Column is if I take a row like this, how many entries are there? Right? That is 3. That's what I'm doing. Take the first one, matrix index 0. As we already said, that is this. Count how many elements are there. Because look, this one is balanced, right? It's like they all have the same number of columns. So the same as doing like 1, a straight 1 here, a straight 1, a straight 1 here. So that is basically how to calculate the number of columns. Do you agree? It doesn't make sense to everyone. So number of rows is length of matrix. Number of columns is length of matrix index 0. Agree? Can we move on?
Yes.
I don't agree.
Okay, we don't agree. Let's go over it again. We don't agree as in you don't agree, or like we should go over again.
Yeah, like I wanted to understand why is it matrix index 0? Like
Okay,
what happened to 2, 3, and all this? So what's the upgrade there?
So look at something. What is matrix index 0? That's why you should ask yourself. What is matrix index 0?
Because matrix index 0. Matrix. Oh, what am I saying?
Look at time.
1, 2, 3, 1, 2, 3. Okay, matrix index 0 should be 1, right?
No, matrix index 0 is a list.
Yeah, it's 1.
It's 1, 2, 3.
Oh, okay.
So if I do the length of that list, I get 3, right, as the answer. Does that make sense to everyone?
Yeah.
Okay. Now the next
I have a question, Cornelius.
Yes, go on, ask your question.
So what if the first the first list in the
What is
matrix,
different length?
like this 1, 2 without the 3, is it still?
Usually the questions they give you, most questions you come across, they are balanced like this. It's like it's n by m. That is n rows, m columns, right? When you see n by, like usually, like you come across very few times you come across something like this, like maybe a matrix like this, like in proportional, like then this one you can't calculate the columns, right? Like because they have like different. Does everyone get what I'm trying to say? Like this is not that common. Like it's possible, but it's not common, right? Because that one, then you can't get the number of columns because some of the columns are longer than others. Then you have to get a column for each of them. But this is like rare, right?
Okay.
Does everyone agree?
I'm still back on this stuff. So a number of rows is just the 1, 2, 3. Yeah, just that.
Number of rows is this horizontal thing. Can you see my highlight? This is the
yeah.
This is 1 row, 2 rows, 3 rows. Row is the horizontal.
Oh, I understood. So now, what about number of columns now? Number of columns is not the element itself. So 1, 2, 3.
So this is actually the column. Look, this is the column. The column is the first column for this matrix is 147. Do you agree? That's the first column, 147. Does everyone agree?
Yeah.
This is the first column, 147. This is the second column, 258. 258. Do you agree? And then the third column, 369, right? So the number of columns is actually the same as the length of any of the rows, honestly. It's not any of the rows. The length of any of the rows. Do you agree?
Yes.
Yeah, it's good to struggle to understand it now. Once you understand it, it becomes a part of you. You never think again when writing the code, right? Okay. Then the next line of code I write is this. I'm showing you how to iterate through. Like, just learn this algorithm. It will save you. You never think. Then the next one I do is I just write for R in range, number of rows, right? So here I can be like current row. I can get a row like this. So now the current row is the same as matrix index R. Do you agree? Do you agree that what is going to be? Does everyone agree that? So if R is 0, I'm going to get matrix index 0, and that will give me this whole one. Does everybody agree?
Yes.
Okay.
Yeah.
Now here I've taken the first one. Look, I've taken the first one. But now I want to get the entries inside because I want to print all the entries 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So then what I'm going to do is that now I'm going to also go a step further. And for my step further, let's switch. And I'm going to say for C in, look, it's a nested for loop. For C in range, number of columns, right? So now I'm going to write value is equal to, look at something. Value is equal to row index C. Do we all agree that if R is equal to 0, so look, if R is equal to 0 and C is also equal to 0, what will the value be? What will value be? What will the value be? So we already established that row is going to be like a row like this. Can we all see it here? Row is going to be a row like this. So if I do row index C, let's assume C is 0, what will the value be? So what's row index?
1.
That is 1. Do you all see it?
Yeah.
And that's
Wait, I have a question.
Yeah, go on.
Can you also, instead of saying end columns, right, can you also do length of row?
Yeah, that would be right. Yeah, it's really the same thing. Yeah. Realize the end of columns is basically the variable I just did here, right? But usually, as I said, I just have a pattern of writing code. So I just initialize this and this, and then I just write my code like this, right? But you can also do length of row here. That will also work, right? Do you agree? Do you understand his question? Do you understand his question?
Yes, what am I saying? So the outside loop will be on index 0, while the inner loop will be on 1. I have to finish 1, 2, 3 before it come back to the outside loop.
So
go to the second one.
Basically, think of it this way: the outside loop is processing the rows. The outside loop will take a row for you. The outside loop will take a row, right? Will take a row. Then the inner loop will step into the rows to touch the entries. So the outer loop takes a row, like 4, 5, 6. Then you come back to your standard list, right? So like here, row looks something like. So row looks something like. Let me switch to this. Row looks something like 1, 2, 3. Then this inner loop will then be like row index C. So if C is 0, value will be 1. If C is equal to 1, to be 2, to be 3. Does that make sense? So here, if I do print val, so this is basically the code to print all the entries inside a 2D list. This is basically the whole code. Now, what if I want to change the entries? Look, if I want to change the entries, it's the same thing, right? If I want to change the entries, I don't think, as I said, once you have this part in place, you are done. If I want to change the entries, again, it is simple. All I have to do is, that one I'm just going to, is the same pattern. I just need to write matrix. Please follow this carefully. This is the last thing about 2D list. Let me jump. So I just have to do matrix of row of column is equal. Let's say I want to set everything to 20. Go to 20. And then I've changed every value there. Or someone can also be like row of C is equal to 20. They'll do the same thing. Because matrix of R is simply row. Can we all see it here? And then it will be 20. Does that make sense to everyone?
Yes.
So just learn this. Just learn this. Just learn how to iterate a 2D list. This is basically it. Go through the rows, go through the columns, and you're done. That is always how you go through it. Easy.
So, excuse me, this 20, is it like it's going to replace 1 to 20? Or
it will change everything here. Well, look, I'm just doing a list assignment. I'm like, for every row, change the index C to 20, right? So it will change this 20, this to 20, this everything to 20, right?
Wow, everything to 20. Okay, cool.
So please.
Cornelius, is there a difference between the matrix, the first one and the second one?
This,
like the
they're the same.
Yeah. Okay.
Because look, matrix of R is basically a variable row, right? Like this line, right? It's the same thing. There's a funny thing, though. Let me show you one funny thing. This is the first one we did. We were like value. Look at this. Everybody, look at this. I beg. We were like value is equal to. Let me use red. we're like value is equal to row of C. Look, please look at this. If you come underneath to write value is equal to 20, that will not change this 1 to 20. It's not do anything. Because the moment you do this, follow me carefully, the moment you do this, value is equal to row of C. Now what is value? It is just an integer. It's a variable kind of integer. If you do this, it will not change it. If you want to mutate something in a list, you have to do this. It has to be your list index. That index K is equal to 20. If you want to change something in a list, you have to index it and then assign it. Does that make sense to everyone? If you understand it, yes in the chat. Okay, good stuff. Okay, so please learn this pattern. Like it will save you. Graphs, all the questions you come across. This is basically how you iterate through them, all of them. So as a challenge, when we are done, try this. Now I realize that this one, so when I write this code, it will print 1, like if I print 1, 2, 3, 4, 5, 6, 8, up to 9, right? Now I want you to take this challenge. I want you to print it column by column. I want you to print it like this: 1, 4, 7, 2, 5, 8, 3, 6, 9. Do you understand the assignment? I want to print column by column. It's very easy. Look, if I want to print by column, it's very simple. Can anybody give me a hint how they think we will do it to print it column? Do you understand what I'm asking? See, this code will print it row by row because look, you take a row, then for every row, you go through its entries and then you print it out, right? But now what if I want to print it column by column? Now I want to print 1, 4, 7, 2, 5, 8, 3, 6, 9. I've come across a person like that in an interview. But they're like, what does code do? You know, how do you think we'll do that? It's the same thing.
Yeah, so for C in range.
Exactly, right? All you have to do is you change this guy, but me for clarity's sake, I'm going to change R. I'm going to also change the R here. And then I'll change these two guys here. That is literally the only things you need to change. Like here. All right. Shama, you know to help us. Just go into that assignment. But basically, all you have to do is that you just flip the for loops, right? You're done. I want you to go into. I want people to try that as a try and send it to the Slack channel. And be like, this is fine. I want everybody. Let's create a thread. If I'm going to send it, everybody reply us to that. Try and write the code and print it. Now, before we go to the Hashish one, I want to show you something very quickly. A tool to use, and also a tool to use for programming, which I actually use, as well as just one last thing. We may even do that. Hashish one going tomorrow. Can you see my screen?
Yeah.
Okay. Okay. There's a Cornell one. I prefer that one, but let's use the general one. So you will be familiar with it. Can we all see this? This is a tool I used a lot when I was programming, when I was learning. I mean, the school I went to, we had a more custom one, which I prefer. But that one is you have to be in the school to have access to it. But this is a tool to use. It will help you a lot. Unless, especially when you get to recursion, it's going to be a game changer for you, trust me. So let's create a first list, L1. Can we all see it here? L1, 1, 2, 3. It's basically going to show you how code is executed. There's also a topic for God next week, but I'm just mentioning it. Then we do L2 is equal to L1. Can everybody see this? Can everybody see this?
Yes.
Yeah.
Do L2 index 1 is equal to 5. So now I want to print L1, and also want to print L2, right? Okay, this is just what we did. So you click, so after you have written your code, click visualize execution. So to show you how Python executes code. Python first executes code. Python does it from top to bottom. So the first go here, L1. So look at here, L1 is a variable, right? Look at this side too, L1 is a variable. So you hit next. I've shown you this. Those of you who have been with us for a long time now, you know, like last year, you're probably familiar with this, but please still pay attention. Don't let familiarity kick in. So look, so the green, so the red one means the line next to execute. The green means you were just recently executed. So we just executed line 2. So look at what happened. It goes to the memory, then it creates that contiguous list, 1, 2, 3. Then it returns the address, right, of it to L1. So this link means, this arrow means the address to it. I can make it even more. I can even actually show, let me see if I can get the Cornell one to actually show you very quickly. So this is that one. I think that one you see the, I mean the same thing. You see that, but now you don't see like the link. Let me give me a second. I just want to show you the address thing. Give me just 1 second. So visualize. So look at this. So I said red means next to execute. Green means was just executed. But I say executed is look. It created the contiguous. It created the list inside your memory, right? and then it returns the address ID1 to it. So that means that whenever I'm looking for L1, L1 actually stores an address, stores a reference to this thing. So in the list, there's a house there, and the address of the house is ID1. ID1 actually refers to the first entry. So on and so forth. I mean, just think of it. This is the address, returns address to this. So if I do L2 is equal to L1, line 3 that I just executed, realize that both of them are pointing to the same thing. They're pointing to the same thing. Can we all see it? They point to the same thing. So it's just one list, and it has two variables, both of them accessing it. Can we all see that? Can we see that? So this is actually what is happening. I'm sure what is happening there. Okay. Now, if I do L2 is equal to L1, so I'm saying like, hey, using L2, change this guy. So now you can see that it has changed to 5. So both L1 and L2 are pointing to the same guy, right? And they both have that 5. So if I print L1, is it 135? As you can see, a program output. And if I print this to L22 is also the same thing. So that's why we're talking about at first, the reference types. It's the same thing we have here, right? They both point to the same thing. As you can see, this is even clearer. They both point to the same thing. So if I change it, I get that. Does that make sense to everyone? Does that make sense to everyone?
Yes.
Okay,
Yes,
let's
yes.
go at the other one we did. Now let's make it a list of lists, right? A list of lists. And let's do that shallow copy thing we did. And now let's first visualize just that one and see. Visualize execution. So we did this. So now look at something here. Let's look at something here. So we first did L1. What is L1? L1 is a list of lists. So what it does is that it first created a list. This is that list, right? This is the outer list. Then inside that outer list, right, we created another list. So that is also another storage in memory. Can we all see it here? So it is a list of lists. Can we all see it here? Does this diagram make sense to everyone?
Yeah.
Does this make sense to everyone? The outer one is a list, right? That is this one. And at its index 0, you created another list there like this, right? Can we all see it there?
Yeah.
So now I'm doing this thing, right? That copying thing. To do that copying thing, look at what happens. It creates a copy of the top level thing. Can we all see a copy of the top level thing? So the first one is here. The second one also, they're independent at the top level. But then inside, it doesn't make a copy of that. Inside, they're referencing the same thing. That's what I mentioned. Can we all see it here? Does this make sense to everyone?
Yeah.
So because of that, now let's make a change. Let's, at the top level, let's add something to L2. Let's add the number 5, right? So look, if I add the number 5, now, the number 5 only went to L2, right? I just added it to L2. So L2 just contains, its first entry is that list, and the second entry is 5. You see, L1 is untouched, right? Can we all see it here?
Yeah.
Okay, but now, if I take L2's first entry, which is this list, right? Same as that of L1, and I append, say, 7 to 8, and if I visualize, sorry, I'll donate in future. Okay, now if I do it, realize that that 7 that I appended, both L1's index 0 has that 7, and L2's index 0 also has that 7. Does that make sense to everyone?
Yeah.
Okay, so this is basically what we're explaining at first. Clear? Clear to everyone?
Yeah.
Okay, so use this tool, visualize the code. So even the matrix code we just wrote, we are like number of rows. So for instance, let's say you have a function called maybe print matrix, right?
Cornelius, can you go back to the code and do like L2 index 0 rather than L2 data?
You said we should do what? What did you say we should do?
I said, can you do L2 index 0 dot append? Yeah, dot append and yeah.
What should we append?
Anything. I want to see if it will affect the both of them.
Yeah, it will affect it, right? It will also. So now, let's do this. Let's print L1. Let's print both L1 and L2. Okay, to make it clear. Okay, so now we have this. So now we are appending 7 and 9 to L2 index 0. So we have appended the 7, right? Green means was just executed. If I append this, so now if I print both of them, so this L1, this is what L1 looks like, as you can see here, this L1, I just printed L1. If I print L2, can you see the list of the first entries are the same, right?
Yeah.
Okay, so yeah, it's very important, very good to know. Let me also show you the other one we also talked about. Let me use this one for the one. Let's open a new tab. The one I like the Cornell one. So we created a first list, and we were like, okay, let's create a list index 0 and let's duplicate it 4 times. 4 times, right? 4 times. Now, unless we have a second option where we are like, okay, let's say we duplicated. So this one takes the inside one, and just the multiplication actually affects the inside one, right? Then we also had another option where we did this.
You haven't closed the square bracket.
Sorry, what did you say?
Okay.
I closed it, right?
Oh, you close it, yeah.
Okay. So now let's visualize.
You've made an error for for underscore.
Oh.
Yeah.
Okay, so now let's look at something here. So let's look at come to execute the first one. Let's see what happens for the first one. Can we all see what happened to the first one? It created that inside list, right? That is here, that inside list. Then it put its address here. Then it duplicated that same address. So every one of these ones is pointing to the same address. Can we all see it here?
Mm-hmm.
Can everybody see it? And this is what we discussed, right? They're pointing to the same things, right? Can we all see it here? That means that if I make a change to just the first one, it's going to affect every guy, right? Can we see here? But let's look at the second one. When I did the second one, it's creating the list. But when I did the second one, right, it created 4 different lists. As you can see here, 4 different lists. And each of them was in a different entry. Can we all see it here? ID 6, ID 7, ID 8, ID 9. They have different addresses in memory. Can we all see it here?
Yeah.
Can everybody see this?
Yeah.
Yes.
Okay, so that means that if I come here and I do like L1 index 0 dot append, let's say 2, and I do L2 and I do, what am I doing here? Did I just paste something I didn't need? Let me just do an assigning. L1 index 0, so let's say 2, and I do L2 index 0, is also equal to 2, right? If I realize that, right? Let me print so everybody will see it. Execute code. So you can see that, sorry. I bet people are not confused about what I'm just doing. Like, I'm just, today, it could be fights. Can everybody see what I just did? I did nothing scary. I just took that entry, that list, right? And I just set its entry to 2, right? Or maybe this will make it clearer. But let's just do that append. Some people get scared when they see those multiple square brackets. All right, and I execute code. You can see that for the first one, it's appended the 2 to everyone. Can we all see here? But the second one, it just appended to the first one because this one is a different address, right? But these ones, they have point to the same address. Does that make sense to everyone?
Yes.
Okay. And finally, we went over let's say you want to write a function to print your matrix, right? To print your matrix. And so you have the matrix, or some people call it board, right? So this basically could I said, so number of rows is equal to the length of your board. Sorry, my nails are very grown right now. So, and then number of columns is also equal to length of board, index 0. And then we can go for R in range. Actually, let's give me just one. I will just finish right now. Please don't fret. Don't be scared. I just want to show you. Like I used this to a lot when I was learning to code. Like when I was learning BSA. Like it helps a lot. So then I'll do for C in range, number of columns, right? So first of all, let's print it. Print my board. The first one is the row. So first index is row. Next one is column, right? So let's just call this function. So let's create a matrix here. Let's call it M. So for clarity's sake, I'm just going to do 1, 2, 3. Then I just do this. I think everybody will see it. 4, 5, 6, right? And let's call print M on M. Okay. We can all see it, but let's visualize it and see what is happening here. So I get my number of, so let's start, I guess number of rows. There are 2 rows, right? As you can see, there are 2 rows. 1 row, another row, 2 rows. Then number of columns is 3 because look, it's just 3 columns. 1, 2, 3, 3 columns. Then for R in range and number of rows, so to first take the first row, R is equal to 0. Then it will go through, so R is equal to 0. So then it's going to take the first row, then to step into it. For C in this, it will step into it. To make it clearer, you can also do this. You can be like current row is equal to board index R. Then it can be like, let me go through the whole length of the row, right? It can be like print that row index C. There are many, many ways to do it, right? Like it will give you the same thing. Right? Please play around with this algorithm and be comfortable with it. It's going to help you a lot. If you see this valid Sudoku question, in the coding rooms, people saw it and I was like, yeah, man, if you've not practiced this, you're going to struggle. I finished mine like a couple of seconds or minutes because I don't think, look, if I show you, like, I don't think I'm writing these codes now. I think this was doing a coding room on Wednesday. Like when I was iterating through it, I didn't think, because if you look at all my codes, you see it's the same pattern. I don't think like, it's like, that's what I'm saying. Like sometimes you just have a way of writing code. And when you get it, look, let's see, when I solved this question 3 years ago, see, it's the same algorithm I've been using. Like, papa, you are there. You don't think. And you're not coming like, how do I iterate through this? Now, those ones should be bonus things on your fingertips. Okay. So I think we spent a lot of time. Let's do the hashing data structure. But I think we'll go through it, God willing, next week. Our topic for God willing next week, we actually talked about a lot of them already. So God willing, we're going to have a lot more time. So I feel like we may have to add another meeting to the week. Or I mean, there's a lot to talk about today. But hey, please go through the hashing data structure. Hash table is like kind of the fundamental data structure to use always, almost always. You use it everywhere. You're always going to use it. There's some comments I have on some of these questions, but it's okay for now. You continue solving the questions. I think we should make our coding rooms kind of compulsory or mandatory. If you want insights in these questions, please come. Please join the coding rooms. Like, it's going to help you a lot. Let me show you something. I joined, like, what I mean is that if somebody starts a Slack huddle and you can join, please join. It's going to help you. It's going to help me. It's going to help all of us. Collapse this for privacy reasons. Let me show you the coding room that took place. When was it? Was it Wednesday or something? I want to show you this. So can everybody see my screen? Okay, so this was, I went through a couple of questions. Like for instance, we take a question then we solved, right? Usually we choose question people were supposed to have solved already, right? So for instance, contains duplicates. It was on our list, right? That was this question. And like everybody should solve it. So we gave like 2 minutes or 3 minutes, everybody should solve this. Then there are many approaches we can use, right? People have different approaches. So as you can see here, we give ourselves time and and let's go to that question. And Lemuel had this solution, Felix had this solution, Wisdom had this solution, I also had this solution, right? But then these solutions will all work, but they're different. Some are better than the other, right? For instance, one solution we considered from Wisdom's own, he had to solve and then do this, but that's his n log n. It's more complicated, right? It doesn't cut it, right? It's work, but the algorithm is better. Then there's the other one where memorizing solution is going to work, but we are like, we're doing if this return true, if this return false. We're like, that is a bit, it's like it works and everything, but the code is not so, let's say, it's not so clear compared to something like this, right? Then we discuss all these things, and it's like, it just makes it work. But then we are like, okay, this algorithm that we are saying is best, right? This algorithm we have here. So this was the algorithm. So this is, I also wrote that one because we're competing with time. So me too, I had to cheat some. But this was the algorithm we first wrote, right? And this algorithm will work. I hope you understand this algorithm contains duplicates. So like, hey, create a set of it. And a set will remove duplicates, right? So like consider the length of the new one, of the set, and of the array. If they're different, that means they are duplicates, right? But then this algorithm is not the best. Why is it not the best? That's something we're explaining here. I'll explain to them that it's not the best because if you take an algorithm like this, you have already created the full set. Like I created the set for the whole list. What if your duplicate occurs just at the end? Then your function can return early. You don't have to go through everything, right? You can just return early. That is why I'm like, this algorithm is much better. Because if you look at this algorithm, right? If you look at this algorithm, let's put that side by side, right? Look at this algorithm. Yeah, we create a set, but we don't populate the whole set, which means that if the duplicate is at the start, we are going to return early. We don't waste that full space to create the whole thing. Because you waste space by creating the full thing and so on and so forth. So please, when the coding room, if somebody starts a Slack huddle, if I have time, I join happily, right? And it's also good because you go and practice these questions and everything on your own and stuff. But if you come in together, as a community, with someone's sound is, let me do this. Okay, like you do these things at the comfort of your room, that is fine. But if you come in together, you're on a call, we are like, let's do content duplicate for 5 minutes. Everybody is trying to rack their brain, right? You get stuck, you're like, oops, I didn't learn it well. It'll help you to make you faster, to make you more efficient. And you get to explain ideas. Because maybe you did this solution you think is the best solution ever, but no, you come in, somebody's like, we could have done this, and you learn, right? That is how you develop. So please be joining the coding rooms. When somebody starts a Slack huddle and you can't join, do the coding with them. Those of you who start, I prefer you first go through questions that are familiar with everyone to keep everyone on their toes, and when you're done, you can go through the other ones. Sounds good to everyone?
Yes.
Okay, and please learn how to read through it like column by column. It's a very simple algorithm, actually, a column by column. Like you can just do, it just becomes, just make it C, sorry, row, C, but you have to flip this one and this one. Okay, that's fine. So,
Hello, Cornelius. I have
Yeah.
just one question.
so we are not going to do, sorry, give me 1 second. We're not going to do the, is there a way to create a priority notification when it's like, I think you probably could to create that. I don't, like for me, let's see, preferences, maybe go to preferences, then go to notifications, and then I think here, I think if you have mute or huddle sounds from Slack, then you not get it. I think go to preferences, then notifications, then set it here. Because look, we have meets like once a week on Saturday. Honestly, that may not be sufficient to, if you want to, because I really want to go through some of these questions with you, because there's some things I want you to take notice of, and things I want you to know. Like this question, for instance, I know some of you have solved this question, and you used maybe what? Use a what? I don't know. You maybe a hash set. But some of you probably use, some of you are probably doing this sorted thing here, which is not the best. Because sorted here is going to give you like kill or key. But since all the entries are strings and they're going to be lowercase English characters, you can just use a list and that will work fine. Because if you use a list, because list is going to be constant, I'm going to be O of 26. It's a beautiful algorithm. This is what I mean. Like this algorithm is much better than this algorithm. But these are things you may never know. But if you meet to go through questions, you probably know it. And I said the job market is very competitive now. So the slightest thing can put somebody ahead of you. Also, it is coding. It's good, right? So please, if somebody starts a coding thing, join. If I see people are not joining, we are going to have to add another hour to our weekly meetings, or we are going to make these meetings longer. But it's Saturday, and people have to go enjoy life. So I don't want to keep you here for so long. Any questions? The person recording can stop as we take questions. We will do the rest of the topics, God willing, next week. Sorry, don't stop the recording yet if you haven't. Let me show you the topics we'll go next week. So that people watch. Okay, can we all see my screen still?
Yeah.
Okay.
Yeah.
Fantastic. Go next week. Pop up, we are going. So officially, we are done with this. Done. I'll touch on the topics go next week, though, but like in terms of our roadmap, you are supposed to be done with this. If you're not done, Charmaine, advise yourself. Okay, so we are done with these ones for now. So let's go to our topics. So God will learn next week. And it's intentional that when I make an update, I send it here so that people will know what is happening, right? It's intentional. I created that. So now God will learn next week. We're going booga booga. This is a topic for God next week, but I've already shown you, I've already introduced you to it, how code works. But you yourself take time and see how Python executes code. It does it line by line. What is happening here? I want you to play with this, with this tool. That's the tool here. I'll send the link. Please play with this tool. When write code, or if you feel this code is not working, please try this tool. Oh, on that note, if you're using the LeetCode, let's assume you want to see how this code is working. When you copy the code like this, look, you see I left the class solution thing out. Just copy just the function you need, the functions you need. If you paste the functions, remove this self thing here, right? If you don't remove it, it may not work. You can even remove the type annotation. You don't need like those types. So like just a check. Okay. So we are doing this week in progress. We are doing big O notation also. I've already introduced big O notation. Yeah, so we are doing this too. We're also doing this. I've already talked about that already, as you can see. And then we go to stacks, citing, and then we go to queues. It's not a lot. Don't cry. Don't cry. This is easily peasily. Right? We are getting there. As you can see, we are almost getting there. These are the main topics we need to handle. So, but don't worry with that. So this is what we are doing. I'll put the resources there latest God willing tomorrow. But at least big annotation. I have the chapter here. Sammy got is the chapter. 2D list. I'll try and see. We're trying to see if we can get more resources for you. Stacks. We have the resources already posted. As you can see, just start munching on them, consuming them. The textbook chapters, if you have time, go through them. Please, like, learn these things. It's fast. You'll finish right now. Stacks and queues, amazing. You need them. 2D lists, I've already shown you. Play around with them. Try to print the column. Try to print the rows. I'll put the process questions here. This is just going to be NEET code 150. Stats. Yeah, and this one's also with the same thing, like queues. I think there's a queues. Same as that. Please, like, don't undermine anything you're doing. Don't trivialize it. It's going to help you, like, gradually realize that, like, if you become complacent at it and you don't work with us, like, you know, the guy doesn't have queue. Okay, don't worry. I'll get you a queue. It doesn't have queue. No, I'll get you the queue questions because you need to know queue more. I'll get you a queue compilation. You need to know queues. You need to know queue. He's my friend. Okay, I'll get you the queue one. Don't worry. I'll create it. I have a custom list. I'll send you my custom list. So this is what we are doing, God willing. Should we add one more? Put it in chat. Should we add one more? Should we add one easy one? Somebody said yes. Did somebody say yes? Because low-key,
No.
look at this. Low-key, the only thing they're going to actually learn is stacks and queues, honestly, for 1 week. For 1 whole week. So, like, because all this I've touched on them, just go and watch the video, like, try it. So let's add 2 pointers.
Yeah, maybe we can add priority queues since it's related to queues. I don't know.
But then priority queues is a bit tricky. The priority queue usually goes with heap, right? Like,
we beg.
but because we've not done trees, yeah, because they are begging, right? Let's just add 2 pointers,
Yeah.
right? I love 2 pointers. Actually, we have a record on 2 pointers from last year. It's an algorithm you should know. I'll teach it very formally. Actually, I'll teach 2 pointers, but I want you to go through our recording from last year or last 2 years. But there's also resources here and learn that. So these are topics forgotten this week. Please munch them. Like this one has lead good questions. So there are not many questions you'll be practicing. So please, this is scheduled for forgotten this week. Please, if you didn't finish last week one, I beg, sacrifice. You know, let's be humble and obedient, and let's go through it. Then we are done. Then go to the next one. We are done. By the time you realize you're top there, right? Again, this week there'll be coding rooms. Please do well to join. Thank you and God bless you. Amen. Okay, please stop the recording and any questions. Let's take any questions.